So in the last video, I talked about OIDC, which stands for Open ID Connect. And this is a standardization of how you can do authentication, where you have multiple clients who need to authenticate with a centralized auth service. So I'm gonna go ahead and just put auth service here. And in that last video, I talked about how you can have a sessions table and you can set cookies. But in a lot of applications, and as people mentioned in the comments, that's not necessarily how it kind of works, because you often have an untrusted client like a phone or an app. So let's just go ahead and put a phone here. And I can just put untrusted client, where you don't have an API that's sitting in between the phone and the auth service, which is typically where you would have put that secret key, right? If you have an API that you own, you could put a secret key here, and then that can kind of communicate with the auth service back and forth to get the actual codes and the tokens, right? But in this case, we're just trying to do an iPhone app that connects directly to some type of auth service like Google's auth service, so that you can then get a token to start using on their APIs. So in this video, I do want to talk about the auth code flow using a PKCE challenge. So those are the key words. If you want to kind of map what I'm teaching, that's something you should kind of remember, okay? Now, I will just try to teach this as is. It's kind of confusing, but I'll come back and kind of explain why we do this, because there is a particular reason in terms of security and people intercepting the code, which is why we kind of make it a little bit complicated, okay? So in this scenario, you are loading up your iPhone app and you want to log into Google or something, right? So the first step is we need to go ahead and redirect the user to Google so they can get a login form to type in their email and their password. Now, in order to achieve this, we actually need to send over some information. So the first thing we need to send over is a challenge, which is basically just a random string that's generated from doing a hash on a secure string inside of this iPhone app, right? So over here, we're going to say like, we'll have a code verifier, and we're going to call this ABC123, right? So the code verifier is going to be used to generate a challenge. So we can say hash ABC123. And then that is what's sent over on that initial redirect to the auth service so that we can actually log in. So we send over a challenge of who knows what this hash will be. And then after you successfully log in with the auth service, it's going to send back a code and try to redirect the user back to like your app name. And then I'll just say like code is whatever, right? So basically you get a one-time use code that you have to then make another request to the auth service so that it can actually give you back some tokens, okay? And in this particular case, we need to send over our code verifier, which is that ABC123 we kind of talked about up here, but then also we send back that code, which was OKJCA, which the auth service sent to us. And then finally, we're gonna get back a bunch of other stuff here. I know this is getting kind of crazy, but we will get back a token, or sorry, an access token, get back an ID token, and then probably a refresh token as well, okay? So at this point, with the access token, you can actually start hitting whatever APIs that, you know, this auth service was trying to give you access to. So if it's like a Google API, I don't know, you can just pick whatever API you can think of. And so now that you have that access token, you can actually start using it in your request that you send over to the API, so that the API can verify that you are someone that should be getting this information, okay? So that's an overall idea of how this auth flow works. Now, I do want to kind of mention why we do this extra complicated logic. And the reason is because if you have a malicious person who's kind of sniffing your traffic, if you don't have this challenge and code verifier in place, and they could potentially just send in the code of OKJCA, right? And then they're going to get back these tokens, and then they can do whatever they want with the API on behalf of your user account. So that's why we have to add in a challenge on that initial request, so that the auth service can kind of hold on to that challenge somewhere. So it's going to take that challenge key that you passed in, and then it's going to generate that one-time code, and they're going to store that somewhere in their database, right? They're going to hopefully have a database somewhere that's storing this information, so that the next time you make a request, it can go and look up and say, okay, I noticed that the first time they tried to do a login attempt, they sent in this challenge, and then later on, when you try to log in again, they sent in this code verifier of ABC123. Okay, so the auth service can run that same algorithm. It can just run a hash over ABC123, and then they can verify that they get BHCHAW back, right? So that's the kind of benefit of doing this, because this hacker, this malicious user, would not know what the code verifier is. This is actually just going to live on the untrusted client's machine, and it's never going to leave it until that very last request. So then at this final point, when the phone sends over the code verifier in the code, the auth service is going to go ahead and just delete that code from the database after it's validated that it's good. And now this hacker can no longer use it for anything. So even if the malicious user were to grab the code verifier at this point in the process, maybe it's sniffing your network traffic, it doesn't matter because this thing is going to probably get accepted first. It's going to delete that code from the database. And now this guy can't even come back and do it again, right? They could try potentially in the future because now they have your network traffic and they sniffed both of those. But it doesn't matter because this is a one-time use code. The auth service is not going to give that information again until you go through that whole process again of generating a new code verifier and a new challenge and getting that all set up. All right, so hopefully I did a good job at explaining this, but you guys will call me out in the comments if there's something I messed up on. But hopefully that was a good overview of how you can use OpenID Connect using this auth code flow PKCE challenge so that your phone can start actually accessing APIs that are behind their centralized auth service. Have a good day and happy coding.